So here, if you see this malachite, so it is having the formula that is having the formula copper hydroxide and copper carbonate, right? So this is the option. Correct option is D. Next, this is the correct option. The chief ore of mercury is. So among these ore, which is the chief ore of mercury? So if you see this, the first option, the pyrrolizite they have given. Pyrrolizite means, so it is the ore of manganese. Okay, manganese oxide that we are calling it as pyrrolizite. So this is not the option because it is an ore of manganese. But what is asking there? It is asking the ore of mercury. Bauxite. Bauxite is an ore of which one? Aluminium. So it is also the correct option. Galena. Galena is the ore of lead sulfide. It is not also correct option. So that is cinnabar is correct. Cinnabar is that it is having the formula mercuric sulfide. This we are calling it as cinnabar. Next, coming to third question, the transition element which shows the highest oxidation state. Okay, among this, which one will show the highest oxidation state? It is a very direct question. That is manganese, because manganese is having the form that is KMnO. Manganese means +7. The oxidation state is +7 in this one. So this is the one which will show the highest oxidation state. Okay. Next, if we take that is iron. Iron, it will show that is maximum oxidation state of +3. Iron will show maximum oxidation state of +3. Okay, it will show +3. And vanadium, it will show an oxidation state of +5. And chromium, as you know, it will show an oxidation state of +6. So highest oxidation state is manganese, it is +7. Right. Next, gunmetal is. So gunmetal is an alloy. So it is, that is, what is gunmetal? So it is an alloy. So what you are going to get here? So it is a combination. So here in gunmetal, you can see copper will be present in more quantity. Okay, it is a combination of three metals: copper, tin, and zinc. So the correct option is B is the correct option. Next, transition elements form colored ions due to. So if you take the salts of the first A group elements, salts of first A group elements means that is what are the first A group element salts we have? First A group elements we have that is NaCl, KCl, everything, all these salts. Lithium chloride, all these are colorless. First A group salts as second A group salts are colorless. Transition elements, it will form, why it will form colored ions? What is the reason? Because of that is a transition will take place by DD transition. So you might have studied about that is a crystal field theory. So what is this crystal field theory? So you have studied crystal field theory or not? In crystal field theory, what happens is the splitting of d orbital will take place. Okay, so that means the d orbital will split into two, that is two sets of d orbitals, E2g as well as EG orbitals, right? So here I will draw that is a CFT diagram. So why transition elements will show that is why transition elements. This is a d orbital, 1, 2, 3, 4. Okay, this is d orbital. So in the presence of ligand, what happens? This d orbital again will splits into two set of orbitals. Understood? So this we are calling it as a T, that is EG orbital, and this we are calling it as T2G orbital. So here, this is one type of splitting. That means crystal splitting in octahedral complexes. If you take crystal splitting in tetrahedral complexes, T2G will be upside and EG will be downside. Okay, whatever it might be. So here, what happens means, suppose if any unpaired electron is present in T2G, okay, if you are supplying that energy, this electron will be jumping into the EG orbital. Okay, so it will shift into the EG orbital. It will split into the EG orbital. When it is split into the EG orbital, what happens means, so the electron will promote from the, that is this T2G to, that is lower energy, to the higher energy. Again, it will come back from the higher energy to lower energy. So this type of transition, okay, this type of transition, what we are calling it as, this type of transition we are calling it as DD transition. DD transition. Because of this DD transition, that means That means electron jumps from the lower energy d orbital to the higher energy d orbital. So because of this d transition, okay, again the electron will jump from the higher energy to the lower energy. When it is coming from higher energy to lower energy, so it will release energy in the visible region. So that we are going to get the color. So because of this d transition only, because of this electron transition from lower energy d orbital to higher energy, we are going to get it. So the correct option is d transition. Next, coming to it, that is 10th question. Duralumin. Okay, duralumin is an alloy. It is an alloy. Okay, so alloy means it is a combination of that is two or more metals that we are calling it as alloys. So here duralumin. Let us. So it is a mixture of how many metals? Okay, so duralumin is a mixture of that is. So remember, duralumin is a metal of. So here in these options they have given. So if this question will come in the examination, so here, so you have to remember one thing regarding duralumin. What you have to remember one thing regarding duralumin means it is a combination of four metals. Duralumin is a combination of four metals. So in first option, is there any four metals are there? No. Second option, no. Third option, no. Fourth option is aluminum, copper, manganese, and magnesium. The combination of four, that is metals. Okay, so magnesium, aluminum, copper. So major combination is aluminum will be present in the major amount. Duralumin, aluminum will be present in major amount. After that, copper. Next, we have that is manganese and magnesium. Understood? Next, the number of water molecules present in more salt. So more salt is nothing but you have done in the practical also. That is FAS. FAS in titrations you have done. Ferrous ammonium sulfate. Okay, you have done in practical examination also. Okay, you have titrated this FAS with K1O4. Okay, in practical examination. This FAS is nothing but it is only more salt. Okay, this FAS itself is a more salt. So it is a double salt. It is double salt means what do you mean by double salt? It is having that is two metals. It is having two salts. Okay, two metal salts it will be having ferrous sulfate and ammonium sulfate. Ferrous sulfate and ammonium sulfate. Here I will write. See, ferrous sulfate and ammonium sulfate. Okay, followed by it is this salt is in association with six water molecules. It is in association with the six water molecules. Understood? So here, what is the correct option for this one? That is C is the correct option. Philosopher's wool on heating with barium hydroxide at 1100 degrees Celsius. So here, what is a philosopher wool? Okay, so philosopher wool. So you have to remember. Okay, so these common names. Okay, so here you see this. This is we are calling it as philosopher. Philosopher wool on heating with barium oxide at 1100 degrees Celsius. Okay, so what you are going to get? So this BAO. Okay, philosopher wool on heating with barium oxide. That means barium oxide is an one compound and philosopher wool is also another compound. So here what you are taking here ZNO we are taking. This we are going to philosopher wool and we are going to get that is BAZN. Right. So here the option is C. Next, which of the following is not an ore of iron? So if you see this option A and C, option A and C, these are the ores of iron. Magnetite, carbonate ore, limonite also ore of the iron. Cassiterite, this is an ore of which one? It is an ore of tin. So this is correct answer. Okay, this is not the ore of iron. Okay, next 14th one, the colorless species they have given. Okay, so what is that? That is a colorless species. So here among these four, which is the colorless species, they are asking for the 14th compound. One is vanadium chloride they have given. Next one is vanadium sulfate. Next to sodium vanadate they have given, and they have given that is one more, that is fourth option. It is a complex they have given. Okay, so here, so if you take the oxidation state, you take the oxidation state for the, that is vanadium chloride. Okay, the oxidation state for vanadium chloride is, that is VCl3. So plus 3 is the oxidation state here. Plus 3 is the oxidation state. Next one, if you take the vanadium sulfate. So this is oxygen is not there. Impression they have given. Vanadium sulfate. Okay. In vanadium sulfate, the oxidation state is plus 2. Okay. Next, sodium vanadate is the having the oxidation state plus 5. Right. So here, if you take vanadium, so vanadium, scandium, titanium, vanadium. So the scandium, titanium, vanadium means 3d3, that is 4s2. Common oxidation. So the electronic configuration, atomic number is 23. That is 3d3, 4s2. 3d3, 4s2. Argon, 3d3, 4s2. Fine. So here, plus 3 oxidation state means, so here, so after removing 3 electrons, how many electrons, what is the configuration for this one? If you remove 3 electrons from here, what is the configuration you will be having? You will be having the configuration that is, first you have to remove 2 electrons from 4s. That means 4s will becomes 0. And remaining 1 electron you have to remove from 3d3. So after removing 1 electron, what you are going to get? 3d2. 3d2 means unpaired electrons are present. Unpaired electrons means colored species. So this option is not correct. Next, vanadium sulfate. If you take the vanadium sulfate, is the plus 2 oxidation state. Plus 2 oxidation state means you have to remove 2 electrons. So 2 electrons you have to remove from the s orbital. So the new configuration is 3d3, 4s0. It is also having unpaired electrons, 3d3. So it is also unpaired electrons means colored species. It is also wrong. Next here it is plus 5 we will be having. Okay, because oxygen is having 4 oxygen atoms. 4 oxygen atoms means how much here? Minus 8. Minus 8 and here it is plus 3, minus 5. If it goes to RHS, plus 5. So plus 5. So in vanadium, plus 5. So this is the general electronic configuration of vanadium, 3d3, 4s2. Plus 5 means you have to remove how many electrons? 5 electrons you have to remove. So 2 electrons you remove from s orbital, right? And 3 electrons you remove from the d orbital. So final, the new electronic configuration will be 3d0 and 4s0. Is there any unpaired electron in this one? No. So no unpaired electron means, so no unpaired electron means, what does it mean? That it is a which species? If there is no unpaired electron is present, right? If there is no unpaired electron is present means, so no, it is no color. It is. So there are no unpaired electrons are present. Okay, so there is no single unpaired electron also. So it is a colorless species. If and so above 2 compounds, if you take above 2 compounds, these 2 compounds are having unpaired electrons. That's why these 2 are colored species. But what they are asking, colorless species. As I said that the color property is depend upon the unpaired electron. So in this sodium vanadate, that is there is no unpaired electron. So in this compound there is no unpaired electron. So no unpaired electron means no DD transition. No DD transition means no color. So it is a colorless species. So option C is understood. If you have any doubts, you can message in the chat box. Okay, fine. Okay, let us go for the, that is new slide share. One more screen share will be doing. Yes. Question number. Wait. Students, are you able to see the screen? Question number 6, 7, 8, 9. Message in the chat box. Are you able to see the question number 6, 7, 8, 9, 15, 16, 17, 18? Please message in the chat box. Okay. Do the question numbers, that is 6, 7, 8, 9. Okay. 15, 16, 17 and 18. Take 5 minutes time. Sixth question, it is that is copper sulfate and potassium cyanide. So they are asking the reaction between copper sulfate and potassium cyanide and what is the product we are going to get. So this is the that is a question based upon the reaction between the two compounds, right? Next, that is the more salt is shown. Just now have asked the question again. We got the more salt here. Okay, which is the more salt. Next, German silver. Ninth question: German silver is an alloy of it. So it is an alloy of three metals. What are those? 15th question: the lanthanide for which positive and positive oxygen state are common. 16th one: among the following pair of ions, the lower oxygen state in aqueous solution is more stable than the other. Next, 17th, F2 is found by reacting K2M and F6. 18th, the color imparted by cobalt 2 compounds to glass. Last 3 minutes, students. Complete fast. Last 3 minutes. Everybody has to do the questions. And please post your answers in the chat box. Last 2 minutes. Okay, students. Try to complete fast. Try to do the questions which you know very well first. Next, you go for the questions which you can do after thinking. So think and do that questions. And the questions which you doesn't know, that leave that questions. Okay, now let us start answering these questions. So here, first one is they have given that is two compounds, a reaction between copper sulfate and potassium cyanide, right? So here, copper sulfate and potassium cyanide. So here, if you see this compound, so this when you are reacting with copper sulfate and potassium cyanide, USO4 and KCN. So what we are going to get here, we are going to get first we are going to get copper cyanide in the place of this. As you know, the sulfate is having the charge. What is the charge of sulfate? -2. CN is having the charge -1. So if you want to displace sulfate, or if you want to substitute cyanide in the place of sulfate, how many cyanide ions you require? Two cyanide ions. Because the total charge on sulfate is -2 and the total charge on cyanide is -1. So you require two cyanide ions to displace one sulfate ion. So that you are going to get 2 KCN. You are going to get copper dicyanamide. So this copper dicyanamide, okay. So on heating, it will convert into copper cyanide, right? Next, further addition of this KCN. On further addition of KCN, what you are going to do? So you are going to get the complex like this. So on further addition of KCN, you are going to get the complex that is 2K3 CuCN. Okay. So here, which is the option you are going to get? Option 3C. Next, which of the following is having the greatest paramagnetic character? So here, for this question, so in order to have the paramagnetic character, so more number of paramagnetic character. So this paramagnetism is it is directly proportional. Paramagnetism is directly proportional to the that is number of unpaired electrons. Number of unpaired electrons. That means more the number of unpaired electrons are there, more will be the paramagnetic. So we have to find the that is ion which is having the more number of unpaired electrons among these. Okay. So if you take copper, copper you have that is the electronic configuration of copper is that is 3d10 and 4s1. Right. If you remove one electron, what you are going to get? You are going to get 3d10. So in this there is no unpaired electron. Next, if you take Cu plus 2, Cu plus 2 means you have to remove two electrons. Two electrons means you are going to get 3d9. Only one unpaired electron is present. And Fe is having that is d6s2. So two electrons you remove. If you are removing two electrons, how many unpaired electrons we have? Six electrons are there. Six electrons means that is one is paired up. Okay, remaining there are four unpaired electrons are present. Fe plus 3. Fe plus 3 means d5 configuration. D5 is 0. D5 means, so how many electrons are present in D5? 1, 2, 3, 4, 5. 5 unpaired electrons. So the correct option is C is the correct option. Fe plus 3 is correct. Next, eighth question is direct question. The more salt is shown by that is option A. Just now we discussed in the previous slide share. Okay. Next, German silver. It is an alloy of three metals. It is an alloy of three metals. What are those three metals? Okay, that is option C is correct. Copper, zinc, and nickel. Next, 15th question. Lanthanide for which plus 2 and plus 3 oxygen share are common in this. Europium, it is europium. Direct question. If you see the electronic configuration of lanthanide, so you will be, so if you are thorough with the electronic configuration of lanthanides, we are going to get the europium. 16th one, among the following pairs of ion, the lower oxygen state in aqueous solution is more stable than the other. Okay. So here, if you take this one, among the following pairs of ions, the lower oxygen state in aqueous solution is more stable than the other. So here this is not correct answer. This is also not. Cr plus 2 no. So the correct answer is Ti, that is titanium, that is Ti plus and Ti. Next, 17th one. F2 is formed by reacting K2MnF6. So here, so when you are taking that is K2MnF6, okay, K2MnF6, K2MnF6 we are taking K2MnF6 and we are reacting with that is So here first let us take this one, and it is antimony, not antimony, uh, stibbium fluoride, antimony, yes, antimony, stibbium fluoride. So what you are going to get here? So this is acting as an Lewis acid. Lewis acid means it can accept that is a pair of electrons. Okay, it can accept that is pair of electrons. That means it is having the vacant sites. Lewis acids generally we are using in that is Friedel-Crafts alkylation association like AlCl3 and FeCl3. These are having the lone pair of electrons. This AlCl3 and FeCl3, these are having the lone pair of electrons. Sorry, vacant orbitals. These are having that is vacant orbitals. So when it is having the vacant orbital, so that vacant orbital can accommodate a pair of electrons. So one of the F minus. So one of the that is F minus will transfer from this compound to this. One of the F minus will transfer from this compound to this compound. Why means because this antimony is having the vacant orbital. Understood? So because of having the vacant orbital, so one of the F minus it can accommodate this one. And thereby what you are going to get here, you are going to get that is antimony hexafluoride plus MnF4. This MnF4 is unstable. This MnF4 is unstable. This upon that is heating, what you are going to get? MnF3 plus half F2. So here the correct answer is SbF5. Next, the color important by cobalt 2 compounds to glass is. So here, so if you are taking the glass, glasses are having different colors. So here, if you are making use of iron salts like Fe plus 2, so you are going to get the green color. And if you are making use of the cobalt 2 salts, you are going to get the deep blue color. So the option is next. Let us go for the next screen share. Just a minute, students. Yes. Question number 19, 20, 21, 22, 27, 28, and 29. Okay. Take 2 minutes time and try to answer these questions. See the questions 19. Which of the following radioisotope is used for anti-cancerous? Okay. All these are fact-based questions. Next, which of the following compound is colored? Colored means again you have to think about that is unpaired electron. Next, the purple color of KNO4 is due to the transition. The purple color of KNO4 is due to the which transition? Next, to obtain silver from silver amalgam, it is heated in vessel which is made up of. Last 3 minutes, complete the questions fast. Last 2 minutes. Okay, let us go for the answering the questions. Which of the following radioisotopes is used as anti-cancerous? So here, so in order to that is uh, so in order to that is for using anti-cancer, so we require that is beta particles. Okay, beta particles and gamma rays. So that means you know that if you take the radioactive element, if you are taking the radioactive element, so it will emit three types of radiations: alpha rays, beta rays, and gamma rays. So in cancer treatment, so we have that means we require that is the rays which are emitting beta and gamma. Okay, so among these three, so which will emit that is beta and gamma rays? Yes, there is cobalt 60. Next, which of the compound is colored? So among these three, so titanium chloride, iron chloride, and COCl2, which of the following is colored? So here, if you take this titanium, it is having +3 oxidation state. TiCl, the titanium is having +3. In iron, it will have Fe +3. Next, in cobalt, what you are having CO +2. Okay. So titanium, so all these are having the unpaired electrons. So FeCl3, if you take this one, it is having the that is light brown color. FeCl3 is also light brown color. Fe+2, light green color. Okay, cobalt, that is it is having blue color, CO+2, and Ti+3. So if you take the titanium, so titanium, if you are taking scandium, titanium, vanadium. Okay, so TiCl3. So 3D2 4s1. Okay, so it will show some D transition. So you are going to get that is D. All of this is correct. Next, the purple color of KNO4 is due to the transition. Purple color of KNO4. So KNO4, what is the oxidation state of magnesium? So +7. +7 means that is 3D5 and manganese 4s2. 3D5 and 4s2. Understood? It is 3D5 and 4s2. So here +7. So +7 oxidation state it is having. It is having +7 oxidation state. So here the purple color is here not due to any DD transition. Okay, it is not any due to DD transition. It is due to the concept called charge transfer spectra. It is a transition called charge transfer spectra. This concept will come in the higher classes. That is charge transfer. Two types are the ligand to metal, metal to ligand. It is not due to any electronic transition. That means the electron won't jump from the lower energy to higher energy. It is due to charge transfer spectrum. Question number 22nd. To obtain silver from silver amalgam, it is heated in vessel which is made up of. So here, to obtain silver from silver amalgam, amalgam you know. So that is mercury containing compounds that we are calling it as amalgam compounds. It is heated in vessel which is made up of. So if you are heating, that is a vessel that is made up of that is iron. So we can get the silver from silver amalgam. Why means because if you are taking copper, nickel, and zinc, so these three compounds that is copper can react with mercury, nickel also can react with mercury, zinc also can react with mercury. So these three compounds, these three metals, copper, nickel, and zinc, it can combine with mercury. Okay, and it can form that is amalgamated compound. Okay, so that's why if you are taking the vessel which is made up of iron and if you are heating the silver amalgam, okay, the silver can be, that means the silver can leave mercury. Okay, the mercury amalgam okay, can be converted into, the silver amalgam can be converted into silver. Okay, the silver amalgam can be converted into silver. When you heat in iron vessel, okay, when you heat in iron vessel, silver amalgam can be converted to silver. Why means because the iron won't react with the mercury, and it won't form iron amalgam. Whereas the remaining, it can react with mercury and it can form corresponding amalgams. Copper can react with mercury, copper amalgam, nickel amalgam, and zinc amalgam. Understood? Next, question number, that is 27. White silver, that is white silver surface turns black when ozone is passed over it. This is due to the formation of silver surface turns black. So this is the silver. This is the surface of silver. Okay, this silver surface has to turns black when ozone is formed. This is due to the formation of. So this is due to the formation of, that is freshly reduced silver, which is black in color. Okay, so there is a reaction, okay, between ozone and silver. So when ozone is reacting with the silver, we are going to get, that is silver oxide. Okay, we are going to get the silver oxide. Okay. Again, what happens means, here this silver oxide, again it will combine with the, this silver oxide again it will combine with the ozone. What you are going to get? You are going to get the, that is, okay, this is due to freshly reduced silver, which is black in color. Okay, the option is B. So in which of the following cases the stability of two oxidation state is correctly represented? So here they have given the, that is 4 options. In which pair the stability of two oxidation state is correct? So one oxidation state is more compared to the other. So here, so manganese, if you take, okay, so this manganese, that is +2 oxidation state is more stable compared to +3. See why here means, so if you take manganese, if you are taking the manganese, so manganese it will show in the, that is the oxidation states from +2 to +7. So in this, +2 is more stable as well as +7 is more stable. Higher oxidation as well as lower oxidation, both are stable. And if you are taking +3 and +4, it will decompose. Okay, it will, that compounds, the manganese compounds which are having +3, +4, and +5 oxidation state, that compounds will decompose to give a lower oxidation state, or it may give the higher oxidation state. Right. So this is the correct option. Okay. So next, if you are taking the, that is 29th question, cuprous ion is colorless, while copper ion is that is colored. What is the reason? Cuprous ion, cuprous, cupric. Cuprous means Cu plus. This we are calling it as cuprous, and Cu plus 2. This we are calling it as cupric. So here, this is colorless. This is colorless, whereas cupric is colored. What is the reason? Same electrons. If it is having unpaired electrons, colored. No unpaired electrons means colorless. That is it. So here, what will be the correct option? So here, if you see this one, both have, no, this is not correct answer. Cuprous ion has incomplete d orbital. This is also not correct. This is also not correct. This cuprous ion has complete d orbital. Why means, if you take cuprous ion, copper, you know what is the oxidation state of copper? Copper, the oxidation state is 3d10 4s1. Cu plus means you have to remove one electron. Cu plus means you have to remove one electron. So thereby what you are going to get when you are removing one electron? So when you are removing one electron, what happens? So the leftover is complete filled. So 10 electrons are there, completely filled. So no color left. So no unpaired electron in this. In Cu plus, what is the configuration? 3d10. 3d10 4s0. 3d10 4s0 means there is no unpaired electron. Right. 3d10 means completely filled. No unpaired electron. No unpaired electron means no color. Okay. So because cuprous ion has complete d orbital, yes, because it is having, that is 10 electrons, complete. And cupric ion has an incomplete d orbital, yes. Cupric ion means Cu plus 2. Cu plus 2 means, what is the electronic configuration? 3d9. 3d9 means, so there will be one unpaired electron will be present. 1, 2, 3, 4, 5, 6, 7, 8, 9. One unpaired electron will be present in the last orbital of d orbit. Okay, last that is this d z square, dx5, yz, zx, x minus dz square. Okay, last orbit, last orbital of the d orbital. Okay, so option is D is the correct option. Okay, students. Understood? If you have any doubts, you can please message in the chat box. Please message in the chat box, students, if you have any doubts. Okay, fine. Okay, students. Next, one more screen share I will show you. Just to take the screenshot because time is not there. Okay, well, one more screen share I will show to you. Please take the screenshot this in your mobile where you can answer. Are you able to see the questions? 24, 25, 26, 31, 32. Students, are you able to see the questions? 24, 25, 26. Please message the chat box. Are you able to see the questions? 24, 25, 26. Okay, please take the screenshot of this and try this. Tomorrow, okay, tomorrow, that means here, please take the screenshot of this one. Tomorrow, please go through the synopsis. Today, you read the synopsis of coordination compounds. Coordination compounds. Tomorrow, we'll discuss coordination compounds. Okay, so please read the synopsis of coordination compounds. Today, you read the synopsis of coordination compounds. Understood? Today, you go through the synopsis of coordination compounds. Tomorrow, we'll discuss that is uh, objective questions and some synopsis based on coordination compounds. Okay, now I am leaving this class. Okay, students.
Anil sir.
Sir. Okay, sir.
Okay.
Leave out my meeting. Okay, sir.
Okay, sir. Just sir.
Okay.
Or one